Well, hey, we are starting Unit 3, which really we're going to do Unit 3 and 4 together and have a test over both Unit 3 and 4 together as a group. This is actually Chapter 13, and then Unit 4 is going to be some parts of Chapter 9, and then we'll have a test over all of that together. But we're going to do Section 13.2 and 13.4 today all together because it's not a hard concept. And it really is repeating what we've already learned, and you'll see that in a few minutes. So our outcome is I can differentiate and integrate vector-valued functions, vector-valued. All right, so before we get into vector-valued functions and integrating and differentiating, I wanted you to have an idea of what a vector is. So if you have physics or you've been in a class that does vectors, a science class or something, then you're going to be right with me and know what I'm doing. I'm just going to introduce this just vaguely, real quickly, what vectors are, just so we have an idea of what we're doing. All right, a vector is a quantity that has both magnitude and direction. It's like a ray, okay? And they refer to them with a V. They can be 2 or 3 dimensional. So this is a picture of 2-dimensional. Here's a picture of 3-dimensional. All right, so in 2-dimensional, this is a vector. So it starts at the origin and it goes to the point A1, A2. So this is going to this ordered pair A1, A2. Okay, so this is vector A, starts at the origin. So this is like its X and Y coordinate of its ending point. And then in 3 dimensions, you can do the same thing. So 3-dimensional, we can have an X, a Y, and a Z axis. So you go out on your A axis, then up on your Y axis, and then vertically on the Z axis. And this is 3-dimensional, so it's sticking out towards us out of the screen. And so this would have the ordered pair A1, A2, A3. And so it's the vector that starts at the origin and goes and ends at this coordinate with the three coordinates, the point with those 3 coordinates. So this would be your X, your Y, and your Z coordinate. So position vectors, which is what I've drawn here, start at the origin. Okay, so a vector is like a ray, and it has a direction, so it will say which way it's pointing, and then it has a magnitude, which is its length. Okay, that's what a vector is. So what if your vector is not a position vector? What if your vector does not start at the origin? All right, so let's say we had 2 points. Point A is x1, y1, and point B is x2, y2. So that's 2 points, and this should mean segment right there. Okay, the vector A with representation for segment AB is going to look like this. A is going to be x2 minus x1, and then y2 minus y1. So if you remember, that's just like finding slope. Y2 minus y1 is your rise. X2 minus x1 is your run. So this is right like your run, comma, your rise. So now this is a number here, and this is a number here. So let me give you some actual values here of what I'm talking about. Let's say our point A was at the point 130. And let's say our B is at the point 25. Okay? So if I were to sketch that, and I'm going to try to sketch it pretty close here. So 1, 2, 3, 1, 2, 3, 4, 5. So I'm going from the point 1, 3 to the point 2, 5. So there's my distance right there. There's my point, my segment A to B. All right, so there's my segment. It doesn't start at the origin. I'm going from A to B. I'll even put an arrow going from A to B. Okay, so now to represent my vector A, I would do x2 minus x1. So x2 minus x1 would be 1. And then I would do y2 minus y1. So y2 minus y1 would be 2. So now this is a vector that starts at the origin and ends at the point 1, 2. So let me sketch that. We've got the point 1, 2. So this is a vector that starts at the origin and ends at the point 1, 2. Notice it is the same length as the segment that went from A to B, and it's also parallel and pointing in the same direction. So what you've done is you've taken these 2 points. When you subtract them, you're actually subtracting the further point minus the one closer to the origin, and it shifts it to the origin is what you're doing. So you're doing the point B minus the point A. So when you subtract point A from point B, it shifts it to the origin. So this is now a position vector. that starts at the origin and goes to the point 1, 2, and it is the same, and now it also has the same length and magnitude as the original segment did. All right, so to find its length, you'll notice it's just the square root of a1 squared plus a2 squared. Well, remember what I told you, this was your rise and your run. And if you remember your distance formula, this is nothing but Pythagorean theorem or distance formula is all it is. So your length, which is denoted by these bars here around the vector A, his name, it's the square root of 1 squared plus 2 squared is what this would be for the problem that I just did. So this is my A1 and this is my A2, A sub 2. So I would have 1 squared plus 2 squared, which is the square root of 5, which is the length of both of these guys. Because if you do a right triangle, you've got a 1 and a 2 on the lengths, so you do Pythagorean theorem, a squared plus b squared equals c squared. So that's 1 squared plus 2 squared. And that's all you're doing when you do magnitude. It's just distance formula or Pythagorean theorem using the position vector, where you start at the origin. So this is the ending point, which really tells you the rise and the run, which is your A and your B on your distance formula, and the Pythagorean theorem. So the magnitude or the length of a vector is found by doing just Pythagorean theorem. So I just wanted to introduce that to you for vectors, okay? So that you would kind of know what it is when we're dealing with these vectors, what they really are. All right, so here's our symbols of what we're going to do. We are going to have a vector valued function called r of t. So here's our little vector symbols. There's going to be a function for the x-coordinate. There's going to be a function for the y-coordinate. So this is your x-coordinate, this is your y-coordinate, and I've got them listed down here. X is f of t, y is g of t. So really, this is not going to be anything new. We are back to parametric equations. We're just looking at them in vector form. So it's just symbols different. That's all that's different. So we are back to parametric equations. All right. So we've got our x function, we got our y function, and they're going to be functions of t. We're putting them together and calling it a vector r of t. So I really don't have to teach you a whole lot of new because it's the same thing, just the symbols of how we represent it on our paper is different. All right, so r of t is a position vector where this f of t and g of t are your x and y coordinates of the ending point. All right, and this point P, f of t, g of t is on some curve. All right, it's the position vector of that point that's on some curve. Okay. Now, you can take derivatives of vector valued functions. So if we have our vector valued function, r of t equals f of t, g of t, then obviously the derivative r prime of t is going to be f prime of t, comma, g prime of t. So all you're doing is taking the derivative of the x-coordinate, the derivative of the y-coordinate. There you go. That is your derivative of your vector valued function. Now, that means that r prime of t is a tangent vector because your derivative gives you your tangent line, right? So r prime of t is the tangent vector. So if you were to graph this vector with these derivatives as its endpoints, that would give you a tangent vector to the curve at P, all right? So the tangent line at points to a curve at point C is going to be a line parallel to this tangent vector, okay? So this is a tangent vector. It's not going to be the tangent line, but the tangent line is going to be parallel to that vector, so it would have the same slope, right? So we're just putting our symbols in vector form. So you just have to remember that your tangent line is parallel. This represents a vector starting at the origin with the same slope as what your tangent lines is going to have, all right? Now, a unit tangent vector, all that means is it can be only 1 unit long, okay? So if r prime of t is your unit vector, that is going to have a certain distance or certain length. So if you divide that vector by its length, which is the r prime of t in these bars, right? That's that a squared square root of a1 squared plus a2 squared. So if you divide the vector by its magnitude, that gives you a unit vector. And so that just talks about the direction of the motion. So since it only has 1 unit length, all right? So don't get confused on this. Don't think more than it is. We are taking this vector and dividing it by its length. So that makes it have 1 unit in length. So it's a unit tangent vector. So now that it's a unit tangent vector, it only talks about the direction. It no longer talks about any length of anything. All right, so it's only talking about direction now. All right, the second derivative of a vector value function is easy to find. If you know your vector is f prime t or f of t and g of t, then your second derivative is going to be the derivative of the first derivative. Okay, so we're just organizing this in a vector. Okay, so these are still our parametric equations. We're just putting their second derivatives in a vector format. So we're not doing anything new. We're just doing parametric equations in a vector format. So this becomes our second derivative and our second derivative of g. So that's the second derivative of the vector r. All right, that's all it is. So you can just take the derivative of each component. And then the last thing we can integrate. If this is our vector r of t, it's f of t and g of t, then we can integrate r of t. We just integrate its 2 pieces. So we would integrate f of t and we would integrate g of t. So you can integrate your 2 pieces. So this is not difficult at all, really, it's not. Okay, so vector valued functions, I'm going to stop the video and make this my content video, but vector valued functions are really parametric equations. We're just putting them in a vector format to where we've got our coordinates x and y or a, b, and c in a vector format in order. All right, so it's not going to be anything different. This is not going to be hard. This is going to be really simple. We're going to spend about a day on this, really, because we're repeating information.